Okay, gee, so you've made the point that basically the sampling distribution is just always normal, no matter what the shape of the population. Is that right?
Or is it? Right? Is it always normal? We'll see. Because there was actually kind of a trick in the last video. I only showed you sample sizes of 25, right? What if we play around with that sample size number? So here, I've adjusted my sampling distribution that's going to come out so that it's not pulling a sample of 25 data points anymore. It's only pulling a sample of 2, right? So let's start this again. Here's our population, and I'm going to randomly sample 2 data points from this, get the mean, and drop it down, right? And we're going to build up a sampling distribution of means down here, right? Is this thing going to look normal? Let's skip to 10,000 samples and look at all the means. Look at that. Well, if you know that your population is normal, then it turns out even for sample sizes of 2, it's going to look normal, right? Let's try for a slightly different looking shape, right? So let's go to a skewed parent population. And here in this simulation, I'm actually going to create 2 sampling distributions of means so that you could compare them. One is going to have an n of 2, just like before. And then the second one down here, I'm going to adjust this so that instead of none, it says mean. And then here, I'm going to put n equals 20. So a slightly smaller sample size and a slightly larger sample size. And when I animate it, it's going to take a sample of 2, and then it's going to take a sample of 20, and then drop the means down, right? And so we're going to see 2 sampling distributions of means being built up, right? So we're going to do 10,000 samples and look at all the means. Oh, this is not looking good for us, right? Here, with a pretty large sample like n equals 20, it seems, yeah, we get what we always expect, that pretty much normal looking sampling distribution of means. But take a look at this n equals 2 one. Right? This is a problem for us. Look at this. It doesn't quite fit under the normal curve. And you could clearly see that this sampling distribution looks much more skewed, right? Take a look right here. The actual means of these sampling distributions, 8.16 and 8.1, they're pretty close to the mean of the population still. But this shape is not what we quite expected. This makes me worried. Let's make a crazy custom distribution, right? So let's make a crazy parent population, because the truth is, in research, you almost never know what the population really looks like. I mean, you might have ideas, but you never really know. So what if it looked crazy like this, right? What if it was like an anti-normal distribution, right? What about something like that? Will we get a roughly normal kind of distribution for our sampling distribution of means? Let's check. So let's take a sample of 2. So it's going to take a sample, drop it down, and now it's going to take a sample of 20 data points and drop down that mean right here. And we'll see, how does the sampling distribution look? Is this going to be at least somewhat normal? What's going to happen? Is this going to be somewhat normal? Let's see. 10,000 samples. This is kind of like doing 10,000. Oh, whoa, I don't know if we thought about that one, right? This looks pretty good. N equals 20 looks pretty good. So now we're kind of starting to feel like, hey, when my sample size is pretty large, I could kind of sit back and relax because I know that the sampling distribution of means will be pretty normal. But when it's n equals 2, take a look at this one. This definitely does not look normal. And in fact, it looks almost like there's 3 little tiny normal distributions in here, right? And let's think about why, right? If we take a sample of 2, we might take a sample from here and a sample from this cluster, and then get a mean that clusters somewhere around in here. But we could take a sample of 2 and both of them might come from this clump in the population. And those means cluster in this area. We might pull a sample of 2 and both of them might come from this area. And those means will cluster there. So that's why we get 3 little peaks in this sampling distribution of means, right? So the moral of this story is, when you have a pretty large sample size, you could basically go ahead and assume that the sampling distribution of means is normal. When you don't have such a large sample size, though, that's when you've got to start worrying, and you might have to think about, what's my sampling distribution of means going to look like?